Hello friends, welcome to the next problem. Problem number 6 of push down automata. The language given is a raised to n, b raised to n plus 1, n greater than equal to 1. Let's get started with the problem. So friends, coming on to the problem, a raised to n, b raised to n plus 1. So till now we were able to establish a relation because a's and b's had some relation in terms of multiples. A raised to n, b raised to 3n, a raised to 2n, b raised to n. So it was either in multiples of 2 or multiples of 3 with more number of terminals. But now it says that b is just one count greater than a. Now solving this problem is actually very simple. The moment I tell you the procedure to solve it, it's sorted. So let me directly dive into that. So now over here, let me assume n's value is equal to 3. That gives me a, b, and one additional b because n's value will be for b as 4. Now let me look at the logic for this. I say over here, look at the logic very carefully. I say for each a, as usual, push one x on the stack. Now the problem is in b, right? B is one count greater than what it had to be. Since we know, since it is confirmed that it is just one count greater, I say let's bypass one of the b's, and that bypassing will be my first b. So I say over here, bypass the first b. So after this I say then for each b pop 1x from the stack. What I mean by that, if you have a stack over here, if the input symbol is this, the moment you receive a push 1x, another a push 1x, another a push 1x. So we know that since I'm in state q0, I receive a and I keep on pushing x into the stack. Now I receive the first b, and if you remember the logic, it says bypass the first b. So bypassing basically means do not do anything on the stack, just remember that I have to eliminate the first b, or I have to not consider the first b. And how am I going to remember that? With a state transition. So therefore I say the moment I get the first b, I say keep b as it is. So b will remain as it is, stack will remain as it is, and please go to a new state, and this is my bypass state, right? And after that it says for each b that you require, for each b that you get after the bypassing of first b, you're going to perform the pop operation again and again. So in my state q1, when you receive the first b after bypassing, I say perform the pop operation and go to q2, and in q2 for all the number of b's keep on repeating the pop operation. So first b I change the state, second b pop, third b pop, and lastly in q2 when you have epsilon and stack top as r, go to the final state. As simple as that, right? So with this logic in mind, let us write the transition function. So friends, my input over here was n equal to 3, so that gave me 3 A's, 4 B's, and this will be my stack for consideration. I have my R over here. Going ahead, I say I am currently in state Q0. Input symbol is A, stack top is R. So if that is the case, the logic clearly said for each a push one x. So without wasting a time, in q0 over this r I push one x and I have the effect on the stack. So this operation is for my first a. Then I am in state q0. Input symbol is my second a, but the stack top is x. Keep on performing the push operation. So this operation will be for all of my remaining a's, signifying a x on the top of each other. Going further ahead, I am encountering a b as shown in zigzag, and we know that it has to be simply bypassed. So what are we going to do over here? I am in state q0. I receive a B and the stack top is X. Do not do anything, but just remember that B has to be bypassed. Therefore, I say go to a state Q1, do not touch the stack, and this state will be called as bypass operation of my first B. Then I am in state Q1. I receive my first B, right? And for every b I'm going to perform the pop operation. So in q1, when I receive the first b and the stack top is x, I simply say, since it is the first pop operation, have a state change. So q2 comma epsilon, signifying this x will be removed from the stack, and this is for my first b's of the remaining three b's. Then I say I'm in state q2. Input symbol is B, stack top is X. I say remain in state Q2 and please keep on performing the pop operation for all of the B's, signifying this is for my remaining B's. So this is going to pop this for individual of B's, and finally what we'll be having is a epsilon. Now over here, finally landed into state Q2. Input is epsilon, stack top is r. As usual, we go to the final state and conclude that this input will be accepted. Let's consider an example for the same. So we have rule 1, 2, 3, 4, 5, 6. Now let's consider an example. So I have, starting with my q0, input is 3 a's followed by 4 b's and the stack top is r. Then I have in state q0, input a, stack top r. Using rule 1, go to q0, 2 a's, 4 b's, xr. q0 on a when the stack top is r. Using rule 2, go to q0, 1 a, 4 b's, xxr. Then I'm in q0 on a, on receiving x, remaining q0, I have bb with me and xxxr. So for 3 a's, 3 x's are pushed on the stack. Further, q0 on b when the stack top is x, for the first time I'm encountering a b that signifies a state change using my rule number 3, and I have 3 b's followed by xxxr on the stack. Further, q1 on receiving b when the stack top is x, first time pop operation will be done, that will be done using my state rule 4, going to state q2, bb and xx are left on the stack. Then I'm in state q2, input b, stack top x. I go to state q2 again, b left and xr. Then I'm in q2, I have b input, therefore I go to my state q2 again because it is a pop operation. Epsilon left on the stack, x removed from the stack, and I have r. Lastly, q2 on epsilon when the stack top is r, using rule 6, goes to qf comma r. Therefore we say this input a b b b will be accepted by push down automata. So with this friends, we complete this problem. See you in the next problem. Thank you.